Okay, we're going to get going on our next session. We have, and I'm going to mess this up, Guillaume. Wow, does that sound French to you guys? Girardin, all right, who's Director of Photonics, Sensing and Display at Yole Développement. And he's going to talk about the three main 3D depth sensing approaches, right, which I think is the stereo cameras and structured light and time of flight. Got that memorized. And the pros and cons and different technical and cost-based advantages and disadvantages for each one. Okay?
Thank you. Hello, good afternoon. So thank you for the introductions. I'm delighted to be here in front of you to present some insight on this imaging business from 2D to 3D. So I would thank you, the organization for inviting us on this show. I'm Guillaume. I'm leading the division at Yole regarding the photonics sensing and display. So photonics, we are from VCSEL illuminations, because when you are shifting from 2D to 3D, you need some illuminations. So we are looking at all those optics, VCSELs, 3D time of flight imagers, but we also involved in the MEMS sensors, and we also cover the other end of the system with some display. So if you take a smartphone, we are from the components to the display, so from the acquisition of the data to the restitution of the data. So my talk today will be about 2D to 3D and how this emerging market of 3D will shape the futures of visions. So I will start with a little brief about the history of imaging. So we consider at Yole we have three main eras in the imaging. So it started with photography and video. So when I'm talking about imaging, we are talking about in consumer market with the cell phone, with smartphones. So all started in the smartphone in the past years. So in 2007, with the introduction of the iPhone. So now more than 2 billion smartphones are sold each year. If you consider one camera per smartphone on average, you find that this business is quite interesting for the players in the supply chain. So we think that the next step where we have been entered recently is the embedded 3D computational imaging. So here you'll find some players like PMD, Core Photonics, Links, who have been acquired. Those guys are dealing with enhanced, improved camera modules with a dual setup or some different approaches we will talk about in a few minutes. So PMD is working on some 3D time of flight imaging. So here you have the main configuration, so dual main or sub-camera, 3D mapping, and some LED illuminations. And the next step could happen pretty quickly in the futures with some embedded 3D interactive imaging. So here it's more about augmented reality, virtual reality, kind of things. And this, by this we mean also some new approaches like multispectral imaging for the futures, like spectrometry or some infrared and terahertz imaging in the consumer business. So we think that things are accelerating in terms of development. And if we look at the different approaches for the imaging, we have a set of techniques to perform imaging. So you have interferometry, time of flight, structural light, laser triangulation, plane optics, stereo vision, computational. So we are talking about single frame 3D, But if you are interested in multiple frame 3D, you have to consider time-gated imaging, structure from motions, and computed tomography. So here you can see that we are covering almost all markets, from industrial, consumer, medical. All the markets are involved and are interested by those different techniques. So today, here you have the different players, relevant players on these different techniques. So Litro for the plane optics, the company Light for computational imaging, where you have multiple cameras that are acquiring multiple images, and you have a reconstruction of the global image, and you can play with the final images. The same with plane optics. You can adapt the focus of your pictures after the capturing. But today my talk will more be focused on stereo vision, structured light, and time of flight. In a first step, I just wanted to give an overview of the market of 3D imaging in a global way, in the big pictures. So here you have our numbers regarding the depth sensing technology on the different markets, from consumer to scientific, defense, and space applications with automotive, medical, industry, commercials. So you can see in 2017, we put a start on the consumer businesses with the iPhone 10, with the introduction of the structured light approach in this TrueDepth camera. And you can see that in the future, it will drive a huge growth for the consumer market, because all the big players like Huawei, Oppo, Vivo, and Samsung are really interesting to match this kind of technology in their systems. So as you can see there, until recently, the industry and commercial application were leading this the application in the 3D and depth sensing technology. So in 2017 and 2018, you see a huge growth of the market. Here we wanted to make some comparison on the mobile phones and the different introduction of technology. So there you have the penetration of the fingerprint sensors on the smartphone. There you have the penetration of the dual rear camera on the different smartphone. And here we have our forecast about the penetration of 3D camera on the phone. So here we have our different scenario before the introduction of the iPhone 10. So in mid-2016, we were forecasting the introduction of some depth sensing camera on the iPhone 10. So we were betting on either on structured light or on time of flight. So now we know that it's structured light approach that has been selected by Apple, but the time of flight approach we think will be one of the good ones for the future. We will talk about that later on. So this time of flight approach has been selected by Lenovo in 2017 on the world-facing on the rear of the phone. So few sales for Lenovo, maybe a few 100,000 sales for this phone. It was a demo for them. But the true breakthrough on this market was the iPhone 10 at the end of 2017. So millions of units were sold. And basically, we see that the adoption of the 3D camera should be quite similar to the other technology, even if the supplying of this technology is quite hard for the others competitors. There were here also big pictures of the market. So there's a little mistake on this one. I think it's 2016 and not 2017. And anyway, 2016 it should be $1.3 billion across the different markets, and over $9 billion in 2022. So that's why there's a lot of people interested in those technology. So let's talk a little bit about technology comparison. So we start with the So the three main technologies that are currently on the market, on the consumer market, are stereo vision, structured light, and time of flight. So here you have a chart regrouping the different specification of those systems. So if you take the stereo visions, those modules can bring you several megapixels of images. You have simple camera, but the configuration of the system is quite complex. I mean, you need to align cameras, so parallax between the two cameras need to be precisely monitored. One of the issues with the stereo vision is the high power computing need, because you have the reconstruction of the different images, and you need some strong, powerful computational powers. You may require some illumination in low light. So those components are best suited for robotic and navigations. And the maturity of such approach is quite high. So here you have the different players on this approach. The second one is a structured light approach. So there you have moderate resolution, I would say. So 1 to 3 megapixels. It requires illumination of the scene with some optics that are quite complex. We will see that later on. The best suited use case is indoor applications. So the structured light approach is the one that has been used by Microsoft in the Kinect, which was developed by PrimeSense, that has been acquired after by Apple. So all the technology done by PrimeSense has been used in the TrueDepth camera from Apple. And those one is more suited for 3D mapping and some face recognition, like on the iPhone 10. And the different players are there. And regarding the time of flight, so this is an approach quite different from the others. We are in the real 3D acquisitions of images. And there you have some difficulties to produce some sensors with high resolution, because the pixels of time of flight system are quite big right now. And people need to shrink the size of those pixels to find some relevant size to put it in your smartphones. So right now, the time of flight approach was used for gesture recognition. So you find some time of flight images in some BMW Theory 5 models. So this is the Sony Soft Kinetic supplying some camera to adjust the volume of the sound in the car. So you turn your hand like this, you increase the volume, you decrease like this, you stop the music like that. You can accept the call by raising the end. So right now, time of flight is, you have these different players on this. So Sony, PMD working with Infineon, STMicro is working on the solution also. So if we look at the different subcomponents in a camera, you'll find, some lens set, optic holders, the sensors for sure, illuminators, and you need an assembly to make your modules. And the thing is, all those stuff are quite easy to find on the market. The thing is, the big value is to make these modules. I mean, to assemble the different components with such precision, to have good performances. This is where the value is. The know-how of the different company involved in those in the design of those modules is quite high. That's why people are looking very, very strongly to acquire those companies, and there are very few on the market to be able to do that. So let's talk about active stereo. So as you may know, the active stereo is based on the parallax analysis of T different point of view from camera. So you can go back to the position of the object thanks to that. So here you have an example of Intel RealSense depth sensors with color camera and 2 depth sensor with infrared stereo camera in the projector lab. Oops, sorry. So regarding the volumes and the value of this market of stereo visions, you have some number there, and the different drones using this kind of approaches. So the DJI Mavic Air is using 2 cameras there to perform some 3D depth sensing. Regarding the automotive businesses, you have iSense and Ricoh that are some players with modules with stereo visions. So in 2017, it was 3 million units, and we estimate that in 2022, more than 32 million units should be shipped for such applications. If we look at the cost of such solutions on the market, the thing is, we divide it in 3 main parts. So the chip, so the different components in the modules, the optic that you put on top of those sensors to make your modules, and the manufacturing, the assembly of the stuff. So there you have some prices regarding the near-infrared global shutter camera you can find, so $3 per unit. If you take the infrared light illumination, around $1, and the classical RGB camera to superpose your different infrared and RGB colors pictures, around $1 per 2 megapixels. Regarding the optics, it is in the range of $1 per component. And regarding the manufacturing, it's around $2 per component. So if you make the total of that, you are in the range of $20 for modules of a stereo camera. And I would like to highlight the fact that the assembly yield is not counted in this result. So it's pretty mature. So now the yield of such assembly is quite mastered. So you shouldn't have a 30% yield for such manufacturing. You are more in the 80 to 90% on that. So it's interesting. So if we look at the structural light, so this is what you find on the iPhone 10. So prior to the release of the iPhone 10, 1 year before, we highlighted at Yole the different use cases and applications that will be enabled by such camera on the front of the phone, because we were convinced at that time that the war will be on the front of the smartphone, not on the rear. And this is what our guess was. So for facial recognition, we thought it will be one of the key applications for some unlocking, for avatar and morphing and emoji. So we were quite right on the different applications that will be leveraged by such camera. But on the dual rear camera, we are still wondering what will be the real use case for such camera on the rear of the phones. So for sure, some augmented reality application could be interesting, but we are not so sure right now. We are not sure there will be a strong move of Apple on this world-facing camera in the next months, maybe in few years. Just a few seconds to show a little bit the workflow of the TrueDepth camera. So first of all, you have, in the first step, when you take your phone, you have some wake-up activation, either on the inertial sensors or when you touch your screens. So it activates a fluid illuminators that you find on the TrueDepth camera. It scans the scene to find a face. If there's a face, it activates the second step, where you have a dot projector, so it projects a pattern on your face, on the surrounding of your face, and then it captures near-infrared pictures of your face with the pattern on it, and it analyzes the 2D. In fact, in the TrueDepth camera, the pattern is there to say, okay, this is a real face. We have a 3D face, but this is not the pattern on your face that make the identification. This is a face recognition on a 2D infrared images, and combined with the neural engine. So I would like to insist on the importance of this neural engine on the Apple solutions, I mean, because if you have so incredible performances on this TrueDepth camera, because the association of this shoot your light approach and also this neural engine, where you have a neural network working to find some point and compare with some templates on the phone and matches and recognize your face. So here you have some pictures of the different how it behaves when you activate the dot pattern from Apple's. So it projects this on your face, and only a portion of this 30K dot projection is used, and I would say to recognize your face. So our sister company, System Plus Consulting, has done a teardown of this TrueDepth camera to analyze what was inside. So here you have the pictures of the different modules. There you have the different, so here, if I remember correctly, so here you have the dot projectors. And there you have the fluid illuminators over there, and the infrared camera from STMicro there. So if we make a cost structures of this module there, you will find that you are pretty similar to what you find in stereo visions. The big difference is about the assembly yield. I mean, at the beginning of the iPhone 10 in September's, October's, we think that the yield of such assembly of the module was around 30, 40, 50% maximum. So the cost of the solution was twice that. So it was $40 for the TrueDepth camera at the beginning of the production. So here you have the different players involved in these modules and the different cost of the component in this camera. There, the manufacturing, so you see that the chip cost on that is pretty high. So you find the global shutter from ST at $3, the proximity and fluid from ST at $1. You have the RGB camera at 7 megapixel at $3 from Sony, and dot illumination and light over there from Lumentum and Heptagon. One other struggling issues with this structure light is what makes the dot pattern on your face, and this is what it's called diffractive optical element. So it's these modules of dot pattern has been done by TIL, Lumentum, Heptagon, and TSMC, and the assembly is done by LG Innotek, and the cost of this is around $7, so it's quite high. Here you have some technology with ceramic substrate and packaging, so this is really space technology in your phones. This is really impressive, and there are very, very few players that can afford this kind of technology and prices on that. So let's be quick on the time of flight approach. So I think you are pretty familiar with how the time of flight approach is working. So you're measuring a time of flight from emission to reception of a photon bouncing back on your object. So here you have a module from PMD there, and it was embedded in the Lenovo Fab Pro 2 phones. So it was related to the Project Tango from Google's. So here you have some specification on the systems. So here you have a side view of the module. So we cut it with System Plus Consulting, and you have here the compositions. If we look at the sensors inside it, so the 3D time of flight sensors. So here you have a big image sensors, because the size of the pixel is around 17 microns. So here you have a comparison of the different size of the pixel. So here you have the classical pixel. So there you have the pixel you find in your smartphone. A Samsung image sensors is about 1.1 microns. If you look at the global shutter pixel, like the one you find in the iPhone 10 from ST, you are in the range of 3 microns in terms of pixel size. And when you look at the time of flight pixels. So in 2017, PMD was at 17.5 microns. So now they are below that. And we think that ST, Sony, that are working on the new generation of time-of-flight sensors are in the range between 10 to 215. So the 8, it's a quite optimistic view. Here we just put in, to make some comparison, an event-based pixel from the company called formerly ChronoCam, which has changed its name recently, I don't remember. Profizi. So now it's called Profizi. And here you have the cost of such solutions. So you are in the range of $30. So it's more expensive than the stereo and structured light approach. So the manufacturing, the assembly, and the chip are one of, you don't have so much optics elements and other spacer to like on the structured light approach. So there's a cost of the solution. And once again, this is with a yield of 100%. So the first, the first product with that will be in the range of $40 to $50, surely. So here, just a comparison between the 3 approaches, so active stereo, structured light, or time of flight. So you have some comparison regarding the cost on the chip, the optics, and the manufacturing, and the total cost of the solutions. So to conclude, for some bullet points, so all approaches on the consumer business are currently being used. So it's combined 2D and 3D. This is not totally 3D. It's not complete 2D approach. We think that before 2020, the time-of-flight approach will have a huge increase in the consumer business. With players like Sony, STMicro, we think that Apple will move to this solution quite quickly. So all solutions involve very high system level. I mean, I would like to highlight the difficulties to produce, to manufacture such modules to make a quite good accuracy in the assembly. You need very, very strong know-how and a lot of expertise in that. And once again, like in every business, I think we need to focus on the use case. I mean, for the iPhone X, the front-facing applications were identified quite rapidly. But when we think about the world-facing, it's a little bit different. I mean, we are not very sure what will be the driver to put a 3D camera on the back on your phone. I mean, to put some furniture from IKEA on your household, it's quite interesting for 2 minutes, but after, I mean, it's not so interesting. So we are still wondering what will drive this world-facing approach. And last remark, structured light and time of flight are highly patented, so it's quite difficult to navigate in those domains. So that's why some players like Samsung, Huawei, Oppo are struggling to find some solution to match the performances from Apple. So it's quite difficult for them to go there. So I think it's okay. Just a few slides about Yole Développement. One second. So we are a market research and strategy consulting company based in France. So we have a different division. So here's mine and the different others divisions. So we have 3 types of businesses. So we do some custom analysis for customers. We have syndicated reports, off-the-shelf reports you can buy on the technology or market side. And we also have some media services and also some financial services. This morning, Rudy Boyer from Woodside Capital made a talk, and we are partnering with them to find some interesting players and to match some interest in the industry between financial advisors and some startup looking for money, or they have developed some technology, and we are here to help them to find money and to find the right application to run after. So that's it. So a few slides. So we are a group of company, but you will have access to those slides. So thank you for your attention.
Thanks. I think we just have time for one question. Anybody have a question? Oh, here's one. Hold on.
Thank you. You mentioned earlier time of flight. That's the future. Is it time of flight for front-facing and world-facing, or just for world-facing? That's question number one. Question number two, the hype was created by Apple with the launch of the iPhone 10 for facial authentication. I think the response is rather mixed in the market. So there's kind of a damper in the industry, but ultimately it can only take off if the ecosystem supports it, the WeChats, the payment systems and stuff like that. And the attention, I assume, must be to replace the fingerprint to save the cost. But that doesn't happen either.
Yeah.
So where do you see this going?
Yeah, okay. To answer your first question, so yeah, we are still wondering which technology will win on the front, on the rear. From what we know so far, we think that the structured light approach and the stereo visions is interesting on the short range distance. I mean, on the front, so it makes sense to make some structured light or stereo vision on the front. On the rear, we think that the time of flight approach is the best suited approach, because we think that the applications driving this world-facing on the rear of your phone will be outside. So we need some immunity against sunlight exposition, these kind of things, and the time of flight solution is the best suited to be immune compared to that. Regarding your second question, this is a question about segmentation of the market. I mean, you won't have a full time of flight approach or a structured light approach for front-facing or rear-facing. There will be some segmentation of the market. I mean, at the low end, if you take a smartphone at, I don't know, $100, the stereo vision with 2 simple cameras will make something. If you want some very high-end luxury phone, we are talking about luxury phone like the iPhone 10, you need some very strong structured light approach or time of flight approach. So people will, I will say, take one, another one. There will be a unique solution for that. And this is interesting. You are talking about WeChat, PayPal for the face authentications. I think this is a key point for players like Huawei, Samsung, Apple to deal with those guys okay, you can use this solution because the false rejection rate on the solutions when some people want to access to your phone, you need some really reliable solutions. And there people will say, okay, so maybe this solution with stereo camera, we cannot access to such features because it's not enough secure for this. You need to jump to a structured light approach or maybe a time of flight approach. So discussions are ongoing on this side. I would say to tell, okay, if you want to have access to, I would say, payments, online payments, you will need those specifications, and you have to provide such modules that are able to give you these performances, to have these features on your phone. If you don't match those requirements, okay, these features won't be on your phones. So this is how we see the market. This is not a unique solution. It is case by case, application by applications. And people are still wondering, okay, where are we heading? Who is using what? I mean, we don't know if Samsung, we know that Samsung is working on time of flight, like Huawei, like Oppo, all those people are working on that. But when it will be released, it's still for maybe low cost, yeah, maybe for low cost smartphone. We don't see something crashing down. I mean, because you have face authentications, you can use fingerprint. I mean, you don't have to rip off some technology because one is best. Sometimes you have some mix of the technology that could be interesting.
Okay, thanks. Great session. Thank you.
Thank you.